Bam. Hi. Today, I would like to talk about what's called nucleosynthesis. Nucleosynthesis. Here we go. Nucleo. When we are talking about nucleo, we are talking about the nucleus of atoms. That's what the nucleo in nucleosynthesis means. So when we're talking about synthesis, it's kind of like a synthesizer that you would use to make music, but we're talking about production or producing. Nucleosynthesis is the process of producing the nucleus of atoms, and that's how we make everything on the periodic table through a process called nucleosynthesis. So what nucleosynthesis is, it is making elements. So we are going to produce elements. If you turn in all of your missing assignments, someone just piped into the chat about this. Absolutely. Your grade can go from an F to an A 100%. All you got to do is turn in your missing work. Yeah. So don't, if you got an F right now, big deal. Do all your work, turn it all in, get 5s on all of it, and you'll have an A 100%. Not even a B, but an A. I want to talk about the different types of nucleosynthesis. There is one type called Big Bang nucleosynthesis. Big Bang nucleosynthesis. It happened during the Big Bang, and we made mostly, what elements did we make? Let's see. Mostly hydrogen and some helium, and then very little lithium and beryllium. So there's a type of nucleosynthesis called Big Bang nucleosynthesis. And that's where all the hydrogen came from. So there's hydrogen in your body right now. My body's 70% water. Where'd the hydrogen come from? H2O. That hydrogen was made in the Big Bang. So 70% of my body consists of hydrogen that is 13.8 billion years old. So I'm not 48, I'm 13.8 billion years old when we're talking about my body's hydrogen, because my hydrogen was made during Big Bang nucleosynthesis. That's only 4 elements. Most of the matter during the Big Bang came out in the form of hydrogen, very little helium. We got all these other elements. Where did the other elements came from? Well, we have a process called stellar nucleosynthesis. Stellar nucleosynthesis. Well, what is stellar? Stars. Stellar deals with stars. So in stars, new elements are getting made up to an element called iron, Fe, which is iron. So stars produce the elements up to iron. Well, iron, if you look at my periodic table, iron is atomic number 26. Well, where did the elements heavier than iron come from? Well, we have to have another process called explosive. Pardon my spelling issues. Explosive, I spell good. Explosive nucleosynthesis. Well, just like the name sounds, explosive nucleosynthesis happens in 2 places: supernova and the plural for supernova is supernovae. So when stars explode, they form supernova. And we also make new elements in hydrogen bombs. And these are the elements heavier than iron. Elements heavier than iron. There's a recent one. I'm going to add another one because we're smart. Neutron star collisions. Neutron star collisions are where all the gold comes from. AU. And that's pretty recent. That's been theorized for a while, but that's pretty new information. We've only had real strong evidence for that for a couple of years ago. So we have 4 ways essentially to make all of the elements on the periodic table. The hydrogen came from the Big Bang. All the elements up to iron are made in stars, stellar nucleosynthesis. If you have big explosions, like in a supernova when a star explodes, or in hydrogen bombs, that material makes the elements heavier than iron. And then if you have neutron star collisions, you can make the elements gold. That's where most of the gold comes from. And it's this explosive nucleosynthesis. It's the supernova that spread all this material out into space. So the elements in my body, I'm mostly hydrogen. All the other elements were made in stars. Well, how did those elements get into me? Those stars had to explode. They spread the material all over the cosmos, and then gravity pulls it all back together again to make our solar system. And everything in our solar system was either hydrogen that was made during the Big Bang or an element off the periodic table that was made in these exploding stars or in these neutron star collisions. I got another one for you. I'm going to slide over a little bit on this because I want to talk about fusion. Doing my best here, guys. I got a little key here. This is going to be a proton. You guys did some research. Protons are particles. They have a positive charge. They're in the nucleus of every element. This is going to be a neutron. Neutrons are particles that are in the nucleus of every element except for one isotope of hydrogen, and they don't have any charge. So what I'm going to do is I'm going to talk about hydrogen, hydrogen, and hydrogen. Hydrogen, it turns out, comes in 3 different flavors: hydrogen 1, hydrogen 2, and hydrogen 3. Hydrogen 1 looks like this. 1 proton. Hydrogen 2 looks like this. 1 proton, 1 neutron. Hydrogen 3 looks like this. These are all isotopes of hydrogen. All hydrogen, they have 1 proton. They differ. Little dyslexic guy, sorry. I've always drawn my B's as D's and my D's as B's. Differ in number of neutrons. Different flavors of hydrogen. Hydrogen comes in 3 different flavors. Hydrogen 1, which is 1 proton in the nucleus. Hydrogen 2, which is it's 1 proton. That's what makes it hydrogen. Every atom of hydrogen is 1 proton in the nucleus. Hydrogen 2 has 2 particles in the nucleus. That's why we call it hydrogen 2. 1 proton, 1 neutron. And we also have a flavor of hydrogen called hydrogen 3, which has 3 particles in the nucleus, 1 proton, and 1 neutron. There you have it. Because I got to talk about how elements are made in stars, I have to also talk about this, helium. It turns out helium, there's an isotope of helium called helium-3, and there's another isotope of helium called helium-4. These are both helium because they have 2 protons in the nucleus, and that's what makes helium helium. Every atom with 2 protons in the nucleus is helium. This particle here, you might have read about it. This is called an alpha particle. So what's an alpha particle? An alpha particle is a nucleus of helium with 2 protons and 2 neutrons. This is like Legos. How do Legos work? You click them together. So I've got my hydrogen in my star, and I've got my helium in my star, and let's do some fusion now. So like if you think about Legos, you just click the blocks together and you make heavier chunks of Lego material. So what we can do is we can do what's called fusion. This is what happens in stars. This is also what happens in stellar nucleosynthesis or not neutron star collision. That's a little bit more technical. But in fusion, what we're going to do is we're going to join nuclei together. So if I take one of these, which is a hydrogen plus a hydrogen 2, well, let me draw this up. It looks like this. That's hydrogen 1. And I'm going to add it to a nucleus of hydrogen 2. What I'm going to get, let's see. If I click my blocks together, I've got 2 protons and 1 neutron. Well, what's that? Well, that's helium-3. And you get energy. So that's what's going on in our star right now. Our sun, hydrogen isotopes, hydrogen 1 and hydrogen 2 are getting smashed together. There's enough gravity and there's enough temperature, there's enough pressure in there for these atoms to slam into each other. They can overcome the electromagnetic force and they can get close enough together that the strong nuclear force binds the nuclei together. And that's called fusion in stars. And that's how you make helium. So something like 1 million tons of hydrogen is turned into helium in our sun every second. And it creates vast amounts of energy. And that's why you stand outside and get a sunburn, because of fusion in your star. But likewise, what I can do is I can come down here and I can take some helium and I can take some helium, and helium-4 looks like this. And I got another little Lego called helium-4 that looks like this. And I'm going to join these guys together and I'm going to get, well, I got 1, 2, 3, 4, 1, 2, 3, 4. So I got 4 protons and 4 neutrons. And then I look at the periodic table and I go, well, what element has 4 protons? And that's beryllium. And this is going to be beryllium-8. And energy. And that's how I get beryllium. So like I start out with hydrogen and I make helium. And then I take some helium and smash it together and I make some beryllium. And eventually I can make all the elements on the periodic table that way. And that's called fusion.